Hey guys, and welcome. This is the introduction to the modern Galileo experiment. And the reason that we're doing this lab, or the objectives that we have, are first of all to compare and contrast the motion of a hovercraft on a flat surface to an object rolling down a ramp. So we're going to use one of these hover disks that we can turn on, fan, and allow it to move on a flat surface. And we're going to compare that with the motion of a bowling ball as it rolls down the ramp from start to finish, and compare and contrast those motions. We're going to use this to introduce the idea of graphs of motion. So we're going to be looking at position versus time and velocity versus time graphs using these two motions as an introduction to that. And we're going to verify or refute Galileo's claim. So Galileo did an experiment many, many years ago where he had objects rolling down a ramp similar to this. But in Galileo's time, he didn't have access to a motion detector. So what he did was he actually set up a series of gates that were equally spaced apart along the ramp surface. And what he did was he would take an object like a bowling ball, something like this, for example, and he would allow that to roll down the ramp, and it would roll through these gates. And in each gate, there was a small little bell. So it would ring the bell, come down, ring the next bell, ring the next bell, etc. And what he would do with that was he would listen for the sound of the bells and try to time how far apart the ringing of the bells was, and use that to try to understand how the object moved. Now, the issue with this is in Galileo's time, measuring time was very difficult to do. In fact, in many of these experiments, he actually used his pulse as a timer, because the clock was really a brand new development at this time, and certainly a stopwatch or a motion detector or something like that was not available at that time. So we want to see, using, more modern technology, if in fact his claim that an object rolling down a ramp experiences equal increases in speed in equal time intervals is in fact accurate, even looking at it with the motion detector. So the way the motion detector works is it sends a sound pulse out to an object. That sound bounces off the object and goes back to the detector. The computer times how long that takes and figures out what the position of the object is based on that. And it does it over and over again in very short time intervals, so we can track the motion of the object as it goes. In this experiment, it will be doing every 20th of a second, so it'll calculate the position 20 times each second. So the first part, we'll take the bowling ball, we'll start it on the ramp, and we'll allow it to roll down the ramp starting from rest. So we'll press collect on the software, and we'll allow it to roll down the ramp like this. And it's going to track the position of the object, and it's also going to track the velocity of the object. You'll see that data in the spreadsheet, and you'll be able to graph that data to see how exactly it moved. We're also going to do the same thing with the hovercraft. So we'll take the hovercraft, we'll turn it on, and we'll place the motion detector on a flat part like so. We'll give the object a push, and then we'll press collect. Now we got a little lip in the table here, but when I actually collect this data, I'll do it on the floor, so we have plenty of space for the hovercraft to be able to move, and it'll track the motion of the hovercraft as it goes across the floor. Again, plotting position and velocity versus time. You'll make some graphs out of that, and then we'll compare and contrast the two motions. So that's the setup for the experiment. What you'll do is take the data, make the graphs of position and velocity versus time for each object, and then use those graphs to be able to answer some questions about the two types of motion.